Okay, it's Alan Weller, University of East London. I just want to go over a few problems to do with Newton's three laws that a lot of people got wrong in the Institute of Physics subject knowledge test. So let's have a look at this first question. A truck is travelling along a level road. It is carrying a large crate. The crate does not slide around on the truck because of the friction between the bottom of the crate and the floor of the truck. The truck is starting from rest and is gaining speed. Which of the following best describes the friction force acting on the crate? So if we have a look at these, there is a friction force on the crate in the forward direction, there is a friction force on the crate in the backward direction, there is no friction force on the crate. So this lorry is accelerating, it's going from left to right. And according to Newton's first law, if this base here had no friction on at all, Newton's first law says that this box here is just going to stay put. So it's going to slide off the back. In order for this box to go forward, it has to have a force in the forward direction. Otherwise, that box is just going to fall off the back. So it's going to have a force like this. Let's just extend it a bit so you can see it. And that seems to go against, we have this sort of sentence that what is friction? It's a force opposing motion. Well, yes, actually in the majority of cases it is, but not in this case. It's a force actually in the direction of motion, and if you don't have it, the box will fall off. Okay, right, that's the first problem. Let's have a look at another problem now. Similar problem. Not involving friction this time. A spacecraft is in deep space, far away from any other objects. A spacecraft engine is switched off. The resultant force acting on the spacecraft is 0. Right, the engine is now switched on and exerts a small steady force on the spacecraft to the right in the diagram above. So in other words, it's going to be going this direction here. After a few minutes, the spacecraft engine is switched off again. What will happen now? Again, this is simply Newton's first law. The fact is, if there's no force on an object, it will either continue at a steady speed, or if it's stopped, it will just stay stopped. And so the answer to this is the spacecraft will continue moving to the right at a steady speed. Right, let's have a look at this next question. A sledge slides down a slope and then onto some level snow. It travels to point B before it stops. Which of the following diagrams best shows the horizontal forces, we're not interested in gravity, on the sledge at point A? To simplify the diagram, the sledge is shown just as a dot. The length of the arrow indicates the size of the force. So what we're looking at is the horizontal force on this. And what are the answers? These 4 answers here. Choose these 4 answers. And let's just go back to it. Newton's first law, if there was absolutely no friction here, it would just continue moving in a straight line. It would just continue at a steady speed, because that's what Newton's first law is about. So, but there will be friction between the sledge and the snow, much less than there would say normally be on a road and the sledge, but there will be friction, and in this case the friction does oppose the direction of motion. So we're going to have a frictional force like that on this particular sledge. So the answer is, if we go back down to here, the answer is B. There'll be a frictional force opposing the motion. So this sledge will de-accelerate. Now let's have a look at one more question. This actually gets a lot of people confused. So we've got here somebody throwing a ball. Jan throws a tennis ball straight up into the air for a short distance and catches it when it comes down again. Think about the ball when it is at A on the way up to its highest point. How would you describe the motion of the ball at point A? So the ball has left her hand. What are these 3 choices? It's getting faster, it's moving at a steady speed, it is slowing down. Well, the answer is what force is on this ball? It's a force, gravity, in the opposite direction it's going to be a single force. Whoa, let's get rid of that. It's going to be a single force like that. So the ball will slow down. Notice the motion is in this direction. The motion is in this direction, but there's going to be a single force of gravity slowing it down. However, there is also going to be a force of air resistance. Air resistance will oppose the direction of motion. So it's going to be the opposite to this arrow here. So it's going to be, if we can move this one over here just to make life easy for me, it's going to be that blue arrow there. So you'll have these two forces slowing it down. And so the answer, if we go to the answer, which of the following diagrams best shows the vertical forces on the ball? It's going to be this one here. Those two forces will combine. You'll have gravity and air resistance combining to produce one force in that direction. If we look, what would the forces be at the highest point? If we had a look at the forces at the highest point, then there would just be a single force. If we there would be no air resistance here because actually it's stopped. There would just be a single force downwards. And again, if we looked at, if we had the ball on its way down here, what would you have? You'd have your force of weight here, but actually, of course, this force here, because if it was coming down, would be in the opposite direction. It would be like that, because the air resistance opposes the direction of motion. Okay, let's just move on to some very tricky questions now. Mostly people get very confused about these directions. This is Newton's third law. A large box is sitting on a level floor. Sam exerts a force forwards to the right on the box, but it does not move. Think about the force exerted on the box, on Sam, while he's pushing. Which of the following statements is correct? So Sam pushes the box pushes Sam, because of Newton's third law, action and reaction. And if we have a look at the answers, the last one is correct. While Sam is pushing, he exerts a force on the box. The box also exerts a force on Sam in the opposite direction to the left. The two forces are the same size. So Newton's law tells us that the forces are equal and opposite. They do not act on the same body, and they're the same type of force. Those three conditions. So the force must be equal and opposite. We've got two masses interaction here. The force is an electromagnetic force. There's no gravity involved here, and it must be equal and opposite. So the last question is right on this one. Let's have a look at another problem here. A lot of people get this wrong. A box is sitting on a floor. The diagram shows two of the forces acting in this situation. Force exerted by the earth on the box, the force exerted by the floor on the box. These two forces are equal in size. So typical example then, might be a coffee mug on the table. Two forces are equal in size. How do you explain this? Right, forces always arise in pairs. And the two forces in a pair are always equal in size. Action and reaction are always equal and opposite. The box is not moving, so the forces on it must be balanced. None of the above. Well, if we go along, let's consider B first. The box is not moving. If the box is not moving, the forces on it must be balanced. So that means the force exerted by the earth on the box, the force exerted by the floor on the box, both equal. It must be balanced. It cannot be going anywhere. So that B is true. And what about A? Forces always arise in pairs. Forces always do arise in pairs. That is Newton's third law, action and reaction. And the two forces in a pair are always equal in size. They are always equal in size. Action and reaction are always equal and opposite. But this does not apply to this situation here, because the force exerted by the earth on the box is a gravitational force. The force exerted by the floor on the box is not a gravitational force. It's an electromagnetic force caused by the bonds between the molecules. So what is the paired force, or the force exerted by the Earth on the box? It's the force exerted by the box on the Earth. The Earth will experience a force by the box. That's the paired force. So number A is wrong, because it is not, these two forces shown in this diagram are not a Newton pair. The paired force must be the same type of force. Okay, let's just have a look at one more here. Again, Newton's law confuses a lot of people. Construction worker pushes on two boxes along the floor. He is able to move them slowly along at steady speed. Which statement is correct? So the middle one is correct. While the construction worker is pushing box A exerts a force on box B that is the same size as the force that box B exerts on A. These two are interacting. There must be a Newton pair. A exerts a force on box B, therefore B must exert the same force on box A. That is the correct answer to that question. Newton's third law, equal and opposite, but not on the same object. Okay, that's the end of this little screencast. If you've got any problems, then you can post on Piazza. Thank you.